Sir, we are the group 5 and for today's topic we will be discussing the sextant altitude by the moon and sun. So here are the members, Decade Casador, Decade Gitigan, Decade Ginoo, and Decade Gudinis. So next slide. So as shown in the table, extract below, corrections for the sun are divided into two parts to allow for changes in sun's semi-diameter during the course of a year. So the first part is for this period of October to March and is based on a semi-diameter of 16 minutes point 15. The second part is for April to September and is based on the semi-diameter of 15 minutes point 9. So next slide. So for example, date is the 20th of May. So we can find the May between the April to September of the month. So the apparent altitude of the sun's lower limb is 10 degrees 47 minutes. So as we can see here, 10 degrees and 47 minutes is in between the 1040 and 1053. So the correction is equals to positive 11 minutes point one. So interpolating as necessary. So next presenter please.
Good day, sir. To continue our report, by the way, I am Decadet Hitigan Kyle Sheldon. To continue our report, we have also here another example. So, full example of altitude correction for the sun. So, the following example shows how altitude corrections for index error, dip, the semi-diameter, refraction, and parallax are applied to a sextant altitude of the sun. So, on 12 February, a reading of the sun's lower limb was taken. Sextant altitude is 14 degree 35 minutes and 0.5 seconds. So our index error is negative 2 degree and 3.3, and our height of eye is 4.2 meters, and our temperature is 20 degrees Celsius. Then our pressure is 2020 MB. So the using struct of the tables A2 above and A4 below. So the calculation for the true altitude would be as follows. So next slide. So our altitude is 14 degree 35 minutes 0.5 seconds, and our IA is equals to negative 2 degree point 3, and our observed altitude is 14 degree and 33 minutes point 2 seconds. So our dip is negative 3 degree point 6, our negative 3 minutes point 6. Then our apparent altitude is 14 degree and 29 minutes point 6. Then our sun's correction is positive 12 minutes point 6. Then combined correction, so our true altitude is 14 degree 42 minutes point 2 seconds. So we have here in the table. So next slide. If the upper limb had been used instead of the lower limb, so the result would be sex altitude is equals to 14 degree and 35 minutes point 5 seconds. Then our IA is negative 2 minutes point 3. Then our observed altitude is 14 degree and 33 minutes point 2. Then our dip is negative 3 minutes point 6. Then our apparent altitude is 14 degree and 29 minutes point 6 seconds. So our sun's correction is negative 19 minutes point 7. Then our true altitude is 14 degree 9 minutes point 9 seconds. So to continue our report, let's have the Cadet Godinez. So that's all my part, sir. Thank you.
Hello everyone, I am Cadet Goodness and this is my part for our report. So, correction tables for moon. The moon's semi-diameter, when the moon is not full, sometimes only the upper limb will be visible and sometimes only the lower limb. In such cases, we have no choice other than measure the altitude of the limb that we can see and to either add or subtract the semi-diameter accordingly. When the upper limb is used, 30 minutes must be subtracted. This is because 30 minutes is the added to the upper limb correction during the compilation of the tables to keep the value small and positive. Parallax correction for the moon. Because the moon is relatively close to the Earth, parallax will be significant and so a correction has to be made. These corrections are included in the altitude correction tables and therefore do not have to be applied separately. Horizontal parallax. Parallax error is greatest when the celestial body is close to the horizon and decreases to zero as the altitude approaches to 90 degrees. It is comparison with the other celestial bodies because horizontal parallax significant in cases of the moon and separate corrections has to be applied. Altitude correction tables for the moon. There are two correction tables for the moon in Nautical Almanac. One for apparent altitude of 0 degrees to 35 degrees and the other is for 35 degrees to 90 degrees. You will see from the extract below that the altitude correction table is divided into two parts. The top part of the table is entered with the apparent altitude and the correction is read from the appropriate column. The lower part of the table is for horizontal parallax and has a different columns for lower limb and upper limb. This part of the table is entered with value of HP, which is obtained from the daily pages of the Nautical Almanac, and the correction is read from the same column as the apparent altitude correction above.
Good day, I am Cadet Tisdor and I will talk about the examples for our report. So our example is at 0200 GMT on 24 December, the sextant altitude of the moon's upper limb is measured and the following data is obtained. So the sextant altitude is 33 degrees 15 minutes, index error is 1.8 minutes, height of eye is 18 feet, and HP is 54.9 minutes. So using the extracts given above, the true altitude is calculated as, so first, sextant altitude and index error. So this is add, we add. Next is for the dip. What we'll do is go to the dip and find the height of eye. Our height of eye is 18 feet. So in between 17.4 and 18.3, which is minus 4.1 minutes. So observe altitude minus the dip, and we got the apparent altitude. And next, for the next correction is get the apparent altitude. So 32 degrees. So here at the right side, 30, 31, 32, 33, that's 32 degrees. And for 12 minutes, it is between 10 and 20, so it's 57.4. So for the next correction is, it's lower since it is 33 degree. No, our HP is 54.9 and the same was the apparent altitude, so it's plus 2.1. So that the sum would be 34 degrees 12.2 minutes. But there is a note here that says 30 degrees is to be subtracted from the altitude of the upper limb. Since we're looking for the upper limb, we will subtract 30 minutes in the correction. So after we subtract, we got the true altitude, which is 32 degrees 42.2 minutes. Another example, on 6th of June, sextant altitude of moon's lower limb, 31 degrees, 32.8 minutes, index error, 2.4 minutes, height of eye, 50 meters, HP is 59.7 minutes. What is the true altitude? So same, sextant altitude, and add with the index error, we got the observed altitude. For the dip, it is height of eye is 15 meters, so we get it from left. So minus 6.8 minutes. Our apparent altitude after the subtraction of the observed altitude is 31 degrees 28.4. So 31 in the middle of 20 and 30, which is 58.2. We add that, and for the HP is 59.7. 7.2, and our true altitude is 32 degrees 33.8 minutes. That will be all for our report. Thank you.